We now come to a second aspect of what was happening in this period. To look at the 1930s, indeed the period really from 1900 forward, as a moment when women were beginning to be able to enter into physics. And I'll choose two to focus on because they're relevant to our story of understanding the nucleus and the new phenomena of particles and their dynamics, and also because both of them, Marietta Blau and Lise Meitner, had been greatly encouraged by Albert Einstein. If you're interested in more writing about the long history of women in physics, I suggest beginning with the work of Margaret Rossiter, whose work on the subject goes far and involves a lot of compilations of data, but also a flourishing field of studies of gender in science that have come into existence over the last decades, and I'll cite some of those in some of the questions. Marietta Blau was born on the 29th of April, 1894, and she lived until the 27th of January, 1970. She was trained in physics and chemistry and tried very hard in Austria to enter into this new domain of the study of radioactive phenomena, of radiochemistry. One of her first ideas, a really foundational idea for modern physics, was very simple to explain, but astonishing in its importance. People had taken photographic paper and used the idea of a particle going through it to see little spots that could be developed on the paper that showed where a charged particle had gone through. Well, what Blau had understood was that you could rotate the paper and that as the particle skittered along its surface, it would leave an entire track. And should the particle, for instance, decay into two other particles, you could see those tracks on it. A piece of film became a kind of laboratory in a box. It was a useful thing to have because Blau was relegated to essentially doing volunteer work at the Radium Institute in Vienna and earning her living by teaching dentists and doctors how to use the new X-ray technology. She collaborated with another woman, Hertha Wambacher, who, paradoxically enough, was a Nazi. So you have this Jewish woman excluded from the center of activity at the Institute, and you have Hertha Wambacher excluded because she's a woman even though she was a Nazi. And the two of them collaborated in using this new method that Blau had invented to image a nuclear star, an event of a kind of nuclear explosion of a single nucleus into its parts. The studies that they made, some of these emulsions, these films exposed at the top of the highest mountains of Austria, went far beyond anything that any other physicist had been able to see anywhere in the world. It was, in a certain sense, the beginning of particle physics. These tracks then gave her immediate fame, and she continued her work. But as things got worse for Jews in Austria, and eventually with the Anschluss, the annexation of Austria by Germany, the situation for Blau became really dire. Einstein wrote recommendations for Blau to help get her out somewhere to a job where she might be safe, including to a Mexican scientist, Ingeniero Balz, and he said this: "It was a great pleasure for me to learn that the eminent Austrian scientist, Dr. Marietta Blau, has got a call to Mexico. I am sure that her large abilities will be useful for the instruction and research activities of your country. For we all know her to be a very intelligent and energetic personality who is trained in many fields. Yours, very sincerely, Einstein." Wambacher stayed in Austria and, despite all, protested about what she considered her shabby treatment. She wrote, for instance, to Nazi headquarters, membership division, in January of 1942. Said this: "I have been an applicant for party membership since June of 1934. As you can tell by inquiring to Circle 9, my status as a party applicant has been in good order even when it was illegal to join the party. In May 1940, I suddenly received a form. My application had been refused. According to word of mouth, there is a large number of upstanding, illegal Nazis being subjected to this shocking and totally un-National Socialistic treatment. I intend to pursue these matters right up to the chancellery of the Führer, Heil Hitler, Dr. Hertha Wambacher. Her protests notwithstanding, Wambacher was gradually eased out, and despite the much more prominent and even more Nazi-affiliated scientists who were above her in the hierarchy of things in Vienna, they were one by one rehabilitated after the war, and Wambacher relegated to obscurity. The work that Blau had done in the late 1930s came to the attention of Cecil Powell, a British physicist. He had been a student of C.T.R. Wilson, the inventor of the cloud chamber, that remarkable device that made images of strings of droplets in a chamber of water vapor. Cecil Powell had gone on to study vaporization processes that occurred, for example, in the explosive eruption of volcanoes. He'd set up little observational seismographic stations all over a Caribbean island where it had a big explosion. So he created a kind of big physics around this tiny technology and taken all of these seismograph readings and combined them to try to predict and understand the dynamics of this volcano, which had been so devastating to Montserrat. When fission was discovered in 1939, Powell suddenly got interested in fundamental physics again, and as he began his notebook, the first thing he did was to review what Marietta Blau had done. He took his methods that he developed in coordinating different groups on the Montserrat Island with these seismographic stations and divvied up a piece of nuclear film into little bits and gave each one of these bits to a different group or a different analyst. These were mostly women who worked with binocular microscopes in cottages around Bristol, and each of them put together pieces of these tracks until he could assemble the whole process. In this way, he built a team that became more and more important with each passing year. After World War II, he really made this incipient new field of particle physics into an experimental domain. It was all that the Europeans could do in a way that Britain, like all the other countries, was devastated by the war. In France and Italy and Germany, laboratories lay in ruins. There was practically no money for fundamental scientific research in Britain. But this small-scale work, in which you had little pieces of film divided up over many different people, became a way of competing with the Americans and their ever-increasing larger and larger number of cyclotrons, this new accelerator physics that was dominating the new world of science. As for Marietta Blau, she went to Mexico, as I mentioned a moment ago, eventually made her way to the United States. She consulted and worked at Brookhaven National Laboratory on Long Island. She made various contributions to physics, but was never recognized for this foundational work that she did in launching the field of particle physics, though she was nominated by some very prominent physicists for the Nobel Prize.